but you can have many minds, each one perceiving differently the same object. They have to be consistent. That's also part of the solution to Kant's anti-monism, because he's right. You have to, the brain has to be consistent, but really, it's okay because we have many minds. So the inconsistency can be in one mind, but you have to keep in mind there's many minds. So if there's different minds, it's okay. Number 28. Einstein really unified relativity and quantum mechanics. His major goal without realizing it, since he unified relativity and electromagnetic theory. For particles act like waves since they exist only in the brain and mind of the physicist. Our mind uses EM waves, or light, to code everything we see. When these objects are very small, then we see the light wave itself, which codes the existence for us. Whether objects in the real world out there are waves of energy, indivisible particles, or divisible to infinity, may be part of philosophy and not the science or physics. That's Kant's second anti-monism. So relativity describes large objects. Electromagnetism describes charges and magnets. And relativistic electromagnetism also describes charges and magnets, taking into account speed and acceleration of charges and magnets at large speeds. When particles are so small, you are really studying the carrier itself, which is an EM wave, or stream of particles, photoelectric effect. Einstein got a Nobel Prize for that. And you use EM for that. And this is on page 10. Or can we unite relativity and quantum mechanics, because his method in relativity is also applicable to quantum mechanics? If you have particles, then you can use the idea that what is really the basis of gravitational relativity, that is that we use light and it has a finite speed. We know its speed. We just apply it to charged particles using electric field and magnetic field. So electric field will depend on the relative motion of the observer. And if we have waves of energy on the quantum level, assuming that the experiments were valid, then we still want to describe the motion of these waves and the force that they exert on other waves or particles. Here too, light is used to observe them. It is human nature so the limit of speed of light causes relativistic effects like in gravity. Assuming that light waves can see energy waves at all, if we can detect it, then it will have relativistic effects on electromagnetic fields equations because of speed of light, because of speed limit of light. But if light cannot detect the most fundamental energy basis of the world, then that is no science but beyond it. However, since the physicist really studies his mind outer sense, and this is mainly his visual field, which is just modifications of light waves, the whole world of the science of physics reduces to light waves, which we understand already. So all physics reduces to electromagnetism. Einstein's theory is just an approximation of photons or EM waves going in our mind. There are just too far many of them for us to keep track of, so we grouped them together as objects having mass, concentrated energy according to Einstein, or density, and used Newton's or Einstein's equations, or treat them as charges. In agreement with Kant, the real object is beyond our mind and is not knowable. Well, at least not with certainty, for there are scientific methods to know these phenomena. Number 29. Einstein did away with inertial frame. The field equations are not from a particular reference frame, since they use tenses, which are equations that are true in all coordinate systems if they are true in one. Number 30. He led to more advanced perceptual theories and similar theories for other faculties of man. We may add emotional factors to perception or create intellectual, imagination, and real relativistic theories as well. Okay, that's the end of page 10. So that was about 30 contributions of Einstein's to physics. Okay, page 11. Number 2, critique of Einstein in physics. A, general critique of physics. Now 1, objects moving almost at light speed. Light can't capture them properly. Number 2, objects moving very slowly compared to light. Number 3, objects too small to be captured by light. Number 4, objects large enough to be well represented by light. Number 5, objects moving faster than light by a lot. Number 6, objects too big to be captured by light. Number 7, objects changing too quickly for light to capture it. Time of change is too short. Acceleration ? Number 8, objects in real time. Everyday space-time. Number 9, objects moving too slow for light to notice them. Change is too long. Acceleration ? Number 10, and more, objects where acceleration of acceleration is ... and also the time the object exists, etc. ? B, Einstein relativity paradoxes. Well, these are problems of physics that Einstein created. Number 1, length contraction. That's a bit hard to believe. Actually, I think somebody says this actual contraction actually takes place. I thought it was impossible, really. I think it was just perception. But in a way, both might be true. It might be possible there's some length contraction, because don't forget, objects are made up of charges. And when they're moving forward, in a way, there might be you're inside the mass. There's charges, and the masses in the front that are being dragged forward are pulling on the ones in the back. There's a force. There might be like a certain contraction there because of that, or something like that. It's another factor. And number Einstein's relativity paradox. Number 1, length contraction. Number 2, time dilation. Number 3, length curvature. Well, that's in general relativity. Number 4, horse and carriage paradox. Number 5, time travel, circular time, grandmother paradox. Number 6, twin paradox. Number 7, relative mass. Number 8, relative energy. Number 9, maximum speed. Max Born says that in general relativity one can go faster than the speed of light, since very far away stars really are in very quick motion because of equivalency of Earth's rotation. Does that refute special and general relativity ? Number 10, light speed independent of motion of observer. Number 11, maximum speed is that of light. Number 12, Max Born, train crashes, but in its reference frame you are moving. The Earth is, so other things should crash. Number 13, space-time is like a sponge, or at 10 to minus 35 scale. I don't know if that's Planck scale. 14, the universe had an origin, but nothing can bring itself out of nothing, according to Aristotle. Number 15, the Kant-Einstein paradox. Space-time is a priori or a posteriori. Some say Einstein is the greatest scientist of the greatest scientist of modern age. Some Abraham Pace says that Einstein is one of the greatest scientists of all time, if not the greatest scientist. It's hard to say. And Kant is considered by many to be the greatest philosopher of the modern times. So they really disagree, so you have to find a resolve their conflict. So the Kant-Einstein paradox, science and philosophy. Number 16, Newton-Einstein paradox. Space-time is absolute or only relative. Number 17, Einstein simultaneity paradox, no distinction of past, present, and future. Number 18, freedom versus determinism paradox. Kant said that it's impossible for us to know if we are free. Einstein rejected free will, as did Aristotle and many others. Spinoza and Maimonides, etc. Number 19, The acceleration of the universe is going on. Einstein only knew that it was expanding, but acceleration would affect Einstein's theory since he identified gravity and acceleration, uh, general relativity, in general relativity. I think part of the reason they say that the universe is accelerating is because they now with telescope they see supernova, and they're so far away that there's no way that they could have gotten that far away if the universe originated in a Big Bang. So they say, aha, so therefore the universe is not moving, expanding. We're wrong. It's not slowing down, it's actually accelerating, even though it's over 10 billion years already. Because of course they're naturalists, physicists. They're not going to say, aha, well, you know what, that proves that God exists, because the galaxies, the supernova must have begun dispersed in space instead of being in one use, because it refutes the Big Bang theory. So you have to believe that the universe is expanding for like about 14 billion years old, and it's still not even slowing down. It's still expanding and still accelerating. You would think that after a while it would be moving by inertia. It would stop the acceleration of the initial force. Number 20, choice of light is the basis of the universe since we know it best, since we use it to see the universe, but also because of dual theory of light as a wave made up of particle. And Joseph Beaton authored that one. Actually, it was a bad choice to use light, really, because you want to make things objective, but light is what we use to observe the world, so it's very subjective. Number 21. Dream of gravitational force is a black hole star. We have regular stars in the universe, and black holes are rare, according to Hubert Rees. Number 22. There may be forces that we didn't discover yet, not just undiscovered particles. Number 23. Are space and time really continuous, or are they discrete? I think Aristotle discusses this problem. Maybe even Kant's second antinomy. Calculus assumes continuity. Well, that is relevant to Einstein's exact solution of the field equations. Number 24, unstable conditions, vulnerability, Einstein. Chaos theory questions the certainty of physical equations in predicting events. Some say that theoretically even a butterfly can distort all the results of physics. Einstein says true science is to be able to predict events, but they're saying, in chaos theory, they're saying even a butterfly can destroy a whole result. It could be an unstable situation. 25. Einstein rejected, well, actually, even Einstein, in his meaning of relativity, he did not consider error in measurements. Even equations have variables, and these are dependent on measurements. And even there are equations, mathematical equations, to find out when you combine variables, what is the combined error of the new function based on the error in the different variables it accumulates. So really, Einstein, even if you got an exact solution of the field equations, the field equations are not exact because they're based on inexact measurements, and the inexact measurement propagates from equation to equation as you combine variables. That's when you have Heisenberg uncertainty principle and other we call them confounding variables, not confounding. Other pairs of variables that you cannot know exactly. Number 25. Einstein rejected randomness, but some believe that the law of causality may be broken. Okay, Max Born. Well, we don't know, but maybe that might be because of Einstein, well, Kant's third antimony suggests that might be possible in the world. But again, this might be well, Max Born said it's a philosophical question. But maybe they're worried about it because of the misinterpretation of the experiments. Number 26, the inapplicability of general relativity to singularities like black holes. Superstring theory is trying to solve this problem. Number 27, what about relativity like the passage of time when sitting on a hot coals versus being in the company of a nice girl? Albert Einstein. Not the kind of relativity Einstein mentioned. Whether you feel pleasure or pain also affects the perception of time. Psychology. Number 28, general relativity presupposes classical mechanics and special relativity. Yet, are these compatible? Author, Joseph Beaton. 29, can you really reduce the force or field of love to Newton's law of equal and reciprocal force? It doesn't seem so. Beaton, author. Newton, Aristotle used to have the force of love, or love of the separate intellect or God, or the angels as the cause of every motion in the universe. But Newton really replaced the force of love by natural forces like gravity. Later they added electric force, magnetic force, nuclear force, and weak force, and strong force, or the color force. But whether love is reducible to this, there's one song that says that without love you're nothing. This, like all these Newton's laws and Coulomb's laws and Maxwell's laws and all these Einstein's laws, seems that really don't need the force of love in the universe. If they're wrong, then obviously the theory is not complete. This is still page 12. C. Quantum theory paradoxes. Quantum mechanics, Heisenberg matrix mechanics, Schrödinger wave mechanics, Heisenberg, Schrödinger, Born, Bohr, and Dirac. Einstein rejected quantum mechanics but contributed to quantum theory. Number 1, breakdown of law of causality. Same cause yet different effects. Number 2, particle can be at several places at the same time. Number 3, limited knowledge of position and momentum of entity. Number 4, wave-particle duality. Number 5, continuity principle of conservation of energy. Number 5, continuity principle of conservation of energy of field with atomic energy when atomic energy is discontinuous. Number 6, Einstein, how can you explain timing of spontaneous atomic level transitions? Number 7, negative kinetic energy. Number 8, Einstein quantum entanglement paradox. Number 9, science philosophy paradoxes elements of matter or reality may or may not be in this physical universe which should depend on extension in space-time. Richard Feynman. Number 10, you really can't see a particle without describing it in the process of observation. Heisenberg uncertainty principle. Number 11, some physicists see it as a problem that there are far more particles than antiparticles. Not really a problem. Their essential difference may be only charge, which is the direction of the spin of the particle. Number 12, quantum mechanics needs general relativity, and yet it is inapplicable to singularities, since general relativity is a theory of acceleration which is equated with gravity. Page 13. And gravity is just an approximation using symmetry of two attractive forces and two repulsive forces between the center of positive charge and the center of negative charge for any two objects. Number 13. Bohr's complementarity principle. He believes that objects sometimes behave as waves and sometimes as particles, depending on the experiment. They cannot have two natures. D. This is both of them together, relativity and quantum theory. Number one, Einstein, relativity physics paradox. Number one, relativity may be too simple, different order. Number two, relativity may be too complex, reducible to algebra. Number two, Heisenberg quantum theory physics paradox. Number one, cause and space-time are premises of science. Number two, number one, causality and space-time are premises of science. Number two, causality and space-time are only known from science. Number three, force, nuclear physics paradox. How can quarks be free if strong force is so strong? Question mark. Number four, need unified theory of general relativity and quantum mechanics to solve problems like the Big Bang. Super revolution, also limits of Einstein. Need new theory to study illusory motion, e.g. motion in a mirror or shadow, television, or future four-dimensional holograms. Okay. Super revolution. Critique of Einstein. We need a new theory since free will changes acceleration of speed. It is also very important whether due to animals, man, angels, or God. Einstein denied free will. I don't know if maybe even a computer can have free will, or at least it has the ability to make choices where it has algorithms. Once you can put algorithms in it and let it in infinite loop, let it go on forever. Okay, a new section. Principles of physics. Newton created classical mechanics. Really, Aristotle created physics, which dominated the world for 2,000 years. Ptolemy and Copernicus and Kepler and Galileo also created physics. Jean Picardie or Galileo discovered the law of inertia, which says that an object will stay in motion unless an external force is applied to it. Galileo also came up with transformations of coordinates depending on the observer's motion. But Newton's theory allowed predicting the future motion given the current motion and the forces acting on it. Newton also unified heaven and earth by showing that laws of motion are the same on earth as in the cosmos. Maxwell unified four laws of electricity, magnetism, and thus predicted the existence of an independent electromagnetic field, which is crucial for general relativity. The Lorentz-Barrett law also lists the motion of a particle in an electric and magnetic field. Lorentz revised the Galilean transformation for objects moving at constant velocity by incorporating the experimental result that light is the same for all observers. The young Einstein took this theory and improved it to create a special theory of relativity. Like Lorentz transformation, it included time dilation and length contraction. But Einstein also added the most famous equation of physics or of science, namely the equivalence of mass and energy. This equation explains many things in physics, including the reason why the stars are shining, while you have nuclear reactions, a fusion reaction. While the young stars, I think it's hydrogen is turned into helium, and then higher up. Later, Einstein created general relativity, which considers accelerating objects, namely objects which move along a curve. An intuitive argument for this is if you have a disk, an observer at the middle, and an object moving along the edge of the disk, then the object will experience length and contraction and time dilation as a tangent or edge of the disk according to special relativity. So equation C is equal to 2 times 3.1459 times r, which holds in Euclidean geometry will not hold. This is for the circumference. Hence you need curvilinear coordinates instead of linear ones to relate the observer and the object. Einstein used key idea that experiments have shown that the inertial mass and the gravitational mass are the same. This might be a mistake because this might be two different points of view, so it might be inappropriate to combine them. Einstein tried to unify the theory of electromagnetism and general relativity. He contributed much to quantum theory, but he never accepted quantum mechanics, either of matrix mechanics of Heisenberg or the later wave mechanics of Schrödinger. Both were later shown to be equivalent. Later on, the physicist Dirac gave a formula to unify special relativity and quantum mechanics. No one gave a unification of theory of general relativity and quantum mechanics. It would be a remarkable revolution to give a general relativistic quantum mechanical theory. Well, I think the key to that may be to First of all, to use equivalence of electricity and acceleration instead of gravity and acceleration, and use you're going to have center of charge instead of center of mass. Okay, general relativistic quantum mechanical theory. It's clear that Einstein's problem was. It's clear what Einstein's problem was and its significance. The physicist Stephen Hawking gave a theory of quantum gravity, but decades before that, Einstein said that he did not think the quantization of gravity is the right approach. I think also Hubert Reeves from Montreal, I think. He won the Einstein Prize. I think he said also that he doesn't think that the quantum gravity approach is the right approach. Also, superstring theory he was skeptical about, which is very popular. Superstring theory tries to unify Einstein's theory of electroweak theory, which is a unified view of electromagnetism and nuclear forces. Physicists say it is so beautiful mathematically not to be true despite lack of evidence till now. Physicists say that it is too beautiful mathematically not to be true despite lack of evidence till now. They wanted to solve the problem of Einstein since his field equations cannot be applied to subatomic level. So subatomic level includes point-like particles. Einstein mentions Einstein knew this problem and said that excluding point-like particles may not be permissible. Yet his theory did that, but they added 6 more dimensions for the universe to make it work. But strings are just collections of points anyway, so they did not do away with point-like particles. They believed that particles are distinct since strings vibrate. Anyway, we believe that it is clear that quantum mechanics does not imply quantization, since the electrons, like planets in the star system, can take any orbit in the atom or molecule. It is just that common nuclei in atoms allow only these orbits to be the unstable or the stable ones. Really, of course, we can have rogue electrons or planets, and they obey continuous or discrete laws of motion. We introduced the equilibrium principle to justify this claim. It means that the force must be of a certain minimum magnitude relative to the particle to cause it to change its motion. It does redefine the law of inertia of Galileo and Newton, one of the 3 laws of classical mechanics. In other words, you have to add inequalities to physics also, besides measurements of uncertainty. Because you might hit, even modify Heisenberg's Nobel Prize uncertainty principle. True, light might hit a particle when you're observing it, causes error, but it has to be significant to actually disturb its motion enough. Or maybe if it's electrons, it might make a difference. Maybe more important is the fact that it takes light time to reach you after it bounces off the electron in Heisenberg principle. And in fact, it might be deflected along the way by gravity or slowed down or something. It also affects perception. I don't know if that's another Nobel Prize right there. Critique of Einstein's theory of relativity. General relativity can be criticized and also praised in hundreds of ways. Here are a few of the main problem solutions, but consider this. Tell the physicists to close their eyes for a moment while they are doing physics, and many of their misconceptions will vanish! Exclamation mark. As will be seen, the relativity theory is really psychological theory of perception, not physics. That is, it is concerned with objects of outer sense in Kantian terminology. Einstein was a realist. He did not distinguish phenomena and phenomena as Kant did. But omitting Kant's proof in the transcendental aesthetic and transcendental dialectic of his book, The critique of pure reason, it is simply a matter to see this, since we use light to see the world with our eyes, and also only after being processed by the brain. Kant even argued that the neuronal world cannot be known by us, so we will briefly discuss Einstein's theory of perceptual relativity. So Einstein really created a theory in a way and made correct predictions to challenge Kant's theory indirectly anyway. But recently I read summaries of Cohen and Nietzsche and Husserl. All three of them in a way give some idea of how to extend and go beyond Kant really. Wittgenstein seems to think that the ego focuses on the analysis of language, analytical philosophy, and he thinks that there's not much philosophy can do except therapeutic. Husserl used to follow Kant, but then later he decided, yes, we can know the world. We're full of pneumona, so phenomenalism. And we can know it by using science and his method. And also Nietzsche argued we can know it by points of view, just like Husserl. And even Cohen used Saint-Exupéry's principles of physics, principle metaphysics. He revised those of Kant, I think. And plus the science of physics to know the world. Plus I gave my own view, which I came up with before I read even these summaries. Later on there were books, Cohen